In this tutorial video, we're going to talk about even and odd functions. So the first thing that we want to talk about is the kinds of symmetry that even and odd functions both hold. All even functions will always have y-axis symmetry, and odd functions will always have origin symmetry. So let's first of all talk about what that means. So let's say that this is my function. It's on the left-hand part of the y-axis. If this function does have even symmetry, it means that this is going to be a mirrored image across the y-axis. So just by tracing this, it should be a mirrored image. Something like that. That's what y-axis symmetry is. For origin symmetry, it's a little bit different. So let's say we started off with the same exact function on the left-hand part. What happens in origin symmetry is you will always go to the diagonal quadrant that you start in. So right now, if I'm in this top left quadrant, quadrant 2, I'm going to have the rest of this function happen in the bottom right quadrant, quadrant 4. And it's going to be a reflected image as well. So what we're going to do is very carefully, we're going to connect this image and get it to look the exact same way as the one that we started with, but reflected across the origin. So here we go. And so starting from here, we're going to connect that, and then we go up, and then instead of going down, we go up. So that's kind of what your origin symmetry looks like. If you are unsure if you're right, flip your picture upside down or look at it upside down. And you can do that right now if you want. But the picture that you ended with should be the picture that you started with if you're looking at this upside down. So that's origin symmetry. Some common functions that have y-axis symmetry are x squared. That's just your parabola. There's x to the 4th, x to the 6th. Those are some common ones, and notice that their exponents are even. Okay. Most times that means that your function is even and will have y-axis symmetry, unless it is involved in a rational function, things of that nature. Another function that happens to have y-axis symmetry is cosine. Your cosine function is an even function as well. And the way that you know, if I were to just sketch this real quick, remember that we always start up here with cosine, and then we go down and then back up. So on the other side, it's the same exact picture, which means that its sister function, sine, is the exact opposite. So sine is an odd function because it has origin symmetry. It goes like this first, and then it continues that pattern in the opposite direction. Okay. Some other common odd functions would be x cubed, and x to the 5th, and x to the 7th, and etc., etc. So there's a couple different ways of proving algebraically that your function is even or odd. And that rule for even functions is this. If you happen to replace all of the x's in your function with negative x, okay, so you just switch the signs on all of them. If you end up with the original function back, it is an even function. For odd functions, that rule is like this. I replace all my x's with negative x, but in the end, my function has switched all of the signs. So everything that was originally positive turned to negative, and everything that was originally negative turned to positive. The only thing about that is that sign change has to be true for every single sign that you see. So let's take a look at a couple examples and see what, how to actually work out this negative x business. Alright, so our first example is going to be g of x equals x cubed minus x. So let's figure out if this guy is even or odd. So we are going to go in and replace all of my x's with negative x's. So there's my equal sign. Everywhere where there's an x, I'm just going to keep an open parentheses right now, and then I'll go back in and change all of them. This can actually be really helpful because it will help you be more careful with your signage. And just to make sure that everything is replaced in the right places. So the x here, negative x, the x here, negative x as well. So we're going to evaluate this and see what we get back. So when I cube a negative, I end up with a negative. And then when I cube an x, I get x cubed. The next part, I have two negatives together, which will yield a positive. And it looks like that's as simplified as I get. So the first question I always ask myself is, did I get the original function back? Is it even? It's always the easiest one to look for. And the answer to that is no. The sign that I started with in the beginning is the x cubed was positive and the other x was negative. So that's not happening. But both of the signs that I started with have both changed. The positive on the x cubed changed to negative, and the negative on the x changed to positive. So remember that when both of the signs change, or all of the signs change, we have an odd function. Okay. Another way to look at that, just so that I'm making sure that I'm showing you everything, is let's say I've factored a negative out, because what we looked at on the previous page is if I plug in negative x, I should get negative f of x. And I just want to make sure that you can see it. So from here, I'm going to factor out that negative. So I take out a negative, what am I left with? What goes inside? And it would be x cubed minus x. Now notice that this entire part right here is my f of x function. So I can actually replace x cubed minus x with f of x and get negative f of x. So this does in fact match that requirement for an odd function. So let's do another example here. Alright, so here we've got h of x equals x squared plus 1. Is it even or is it odd? So here we go. We're going to go ahead and start. I'm going to put parentheses where my x's are, just to make sure that they are all in the right place. There's negative x, and we're going to simplify. So when I square a negative, what do I end up with? If you said positive, you are correct. So when I square the x, I now just have positive x squared. Plus 1, there's nothing to do with that. And so now it's time to analyze. Is this even or is it odd? And it looks like this is the exact same thing that I started with, which makes this even. Okay? What about the case where it's neither? Can that actually happen? I'm going to show you that on this same exact page. Okay, so over here on the right hand side, I'm going to show you a case where it's neither even nor odd. So here we've got a function x cubed plus x squared. So again, I'm going to go ahead and put parentheses where I've got my x's and replace them with negative x's. So again, I cube a negative x and I get a negative back out and an x cubed. The next part, when I square a negative x, I get a positive x squared. So, oops, that's not x squared. What am I doing? There we go. Alright, so when we compare this to the original, the sign on my x cubed went from negative in my answer from positive, right? So that sign changed, but the second pair of signs did not change. I ended up with a positive x squared, and I started with the positive x squared. So because neither or both of those signs did not change together, it does not fit the odd function requirements. And also, because both signs didn't stay the same, it doesn't fit the even requirements either, which makes this neither even nor odd. So those cases do exist. So you actually have to try out both, or all three, I should say, before you make your final answer. So that's all there is for even and odd functions, and that will conclude this tutorial.